So here's my polynomial entered into my graphing calculator. Notice I forgot to mention this before, but I wanted to compare to 0. So if you're not equal to 0 or less than 0, make sure everything is moved to one side so we can compare to 0. So I'm going to go ahead and actually take a look at the graph first. So here is what the polynomial looks like. And we can see that it does have zeros at -1, 0, and 2, just like we knew. The reason that we check those is because that's where the graph may change directions. If I pick a number, let's say smaller than -1, like this part of my graph, I can see that the graph is below me. So using the graph method, I know the graph is in the negative section, okay? If I take a look at the graph between -1 and 0, the graph is actually above the x-axis, so I drew an arrow pointing up. And then we keep going for each interval. So between 0 and 2, the graph is actually below the x-axis, so it points down, that's where it's negative. And then if I take a section over here above 2, when x is bigger than 2, the graph is above me, so I drew an arrow pointing up. So I've kind of gone through and labeled where the graph is pointing up or where the graph is down. In other words, where it's positive or negative. The problem asked me to find out when my graph was less than 0. And so the intervals would be where the graph is downwards. So from -infinity to -1 is one of my intervals. Notice I included parentheses because I didn't want to be equal to 0. At -1, the graph is 0. So I have parentheses because I don't want to be equal to it. In addition to that, that's what the U is for union. Between 0 and 2, the graph was also below the x-axis. Okay? So there's a way to use your graph, but there's a way to use your table as well. So let's go ahead and switch over and take a look at the table. One thing that's nice about using the table approach is that I can find my zeros. As long as they're integers, I can find what my zeros are as well. So if I don't want to factor, like some of these in the next videos aren't going to be factored for us, I can take a look at the table, and wherever y is 0, those x values are the zeros, okay? The way this process works, and a lot of people like this better, is all we have to do is pick a number in each interval, an x value, and then see what the y value is, what the sign of it is. So pick an x value that's smaller than -1. So let's say like -2 or -3. And I can see that no matter what I pick, the y value is always negative. So I put a negative sign on my number line. Pick a number between -1 and 0, and that might be tough unless you switch your table over to take a look at decimals. That's why it's nice to use both of these ideas together. We already said between -1 and 0, the graph was above the x-axis. So if I did change my table, this y value would come out to be positive. Pick a number between 0 and 2, so 1 would be a good choice. And I can see that once again my graph is going to be negative in that section because the y value is negative. And then finally pick an x value that's bigger than 2, so maybe 3 or 4. And I can see that the y value is positive. So what some of you are probably noticing is that my signs alternate. That's sometimes the case, but not always. I can imagine that if the graph maybe just came and bounced off that 0, if we had a double solution, the sign wouldn't change. But for the most part, yeah, usually it does alternate. So once again, I was checking to see where the graph is negative. The two intervals where the graph was negative, just like we saw using the graph, if we use the table, anywhere from -infinity to -1, the graph is negative, and also between 0 and 2. The graph is below 0 and negative. So those two intervals represent my solution.